How are humans changing the Earth and its systems? When did we start changing how everything works? Is there any way we could go back to how the Earth's systems were before? These are a few things we will explore in this video through the 3 points explaining Anthropocene, a rejected geological epoch. And this is the insufficient summary providing a quick breakdown of different subjects and ideas in our social world. Point number 1, background. The Earth is 4.5 billion years old, and its history can be traced in Earth's rocks and fossils. Researchers examine these rocks and fossils to understand how the organisms found within them are characteristics of certain periods of time, also known as epochs. Currently, we are in the Holocene epoch, which began after the last major ice age almost 12,000 years ago, although certain scientists believed we have moved into a new epoch called Anthropocene. Some scientists argue that we are living in the Anthropocene epoch because human activity have changed the Earth and its systems more than all natural processes have combined. The dramatic increase in human activity affecting the planet can be traced to modern human civilization that have developed within the last 10,000 years, and the success of our existence has changed Earth's systems outside its limits, causing disruptions and changes in climate and ecosystems. Point number 2, terraforming and its consequences to Earth. Terraforming is the act of changing the Earth's surface for human needs. Humans dominate 75% of ice-free land because of mining, agriculture, industrialization, and urban growth. 38% of it is now devoted to agriculture alone. Human activities started to have significant impacts on the planet's climate and ecosystems in the Industrial Revolution that began in the 1800s, which put a great amount of carbon and methane into the atmosphere. These impacts continued onwards, and in 1945, new damaging particles were introduced onto Earth's surfaces when humans tested and used an atomic bomb. The radioactive isotopes and particles from the atomic bomb were detected in soil samples globally. After World War II, the 1950s began what is called the Great Acceleration, which are human-driven global trends that began after World War II and into the 21st century. These trends include population growth, energy use, greenhouse gases release, and technological advancement. Perhaps the greatest consequence from the Great Acceleration that has and continued to have significant impact on the Earth's natural systems is one that is invisible to us. That is the change in the composition of the atmosphere. Carbon dioxide emissions are colorless, odorless, and in an immediate sense, harmless. But their warming effects could easily push global temperatures to levels that have not been seen for millions of years. Currently, carbon dioxide levels in the atmosphere are higher than at any other time in the past 66 million years. Animals and plants are already shifting their ranges toward the poles to avoid the heat. Some species will not survive the warming at all. All the while rising temperature are raising sea levels at almost 2 centimeters a year and approximately 6 meters or 20 feet or more since the Great Acceleration. Additionally, we are still burning billions of tons worth of coal and oil, leading to massive carbon dioxide emissions, which continues to warm the planet and seeps into the oceans and acidifies them. The acidification may lead to a point where corals can no longer construct reefs in this century. Coral reefs are home to more than 25% of all marine life and are considered as one of the most complex ecosystems. Corals have existed for 450 million years, but ocean warming and acidification has caused widespread bleaching and can eliminate all coral from the oceans before the end of the 21st century. With the amount of carbon dioxide emitted into the atmosphere, forests across Earth, which are natural carbon sinks, can absorb carbon dioxide and help reduce levels of it in the atmosphere. Unfortunately, deforestation for the lumber trade, urbanization, mining, and agriculture have caused limitations to neutralize the amount of carbon dioxide in our atmosphere. Furthermore, deforestation results in major loss of forest habitat that has caused extinctions, which are now happening at rates hundreds or even thousands of times higher than during the most part of the past half-billion years. If current trends continue, the rate may soon be tens of thousands of times higher. That is because the Earth's forest is home to 80% of terrestrial biodiversity. However, 85% of the Earth's forests have been cleared, fragmented, or degraded for human use. Those figures are only accounting for forest habitat loss causing extinctions. If we were to account for extinction caused by poaching, pollution, climate change, and hunting on top of habitat loss, extinction rates are up to 10,000 times higher than natural rates. Earth has had 5 great extinctions. We are now in the middle of the 6th, this time because of human activities. With carbon sinks unable to lower carbon dioxide levels in the atmosphere even though forests across the globe annually absorb 30% of anthropogenic carbon emissions, climate change will continue to run rampant, creating unstable global temperatures, extreme weather events, sea level rise, and ocean acidification across the globe. To make matters worse, with the amount of carbon dioxide in the atmosphere, it has put our climate system in a state where there is no analog for future projections, meaning, climate in the future cannot be compared to the past. The consequences of terraforming can be examined by looking at technofossils. Technofossils are human-created objects such as plastics, concrete, and aluminium that will persist in the biosphere long after we are done using the materials. The most obvious way humans are altering the planet's ecosystems is building cities, which are essentially vast stretches of man-made materials such as steel, glass, concrete, and brick. Millions of years from now, evidence of these materials will still be found in the rock's layers. In its entire aggregate, human-created material is estimated to be 32 trillion tons. This number will only continue to grow as the global population continues to rise, which inevitably will create more waste, as it is estimated that the world's population can reach 10 billion by 2050, with most people living in and migrating to large urban centers. To fit the growing population, it will require the creation of new cities or expanding old ones, leading to more technofossils left by humans. Point number 3, can we go back? In short, the answer is no. Human-created effects on the planet, such as radioactive isotopes from atomic bomb testing or soot from coal-fired power plants, are embedded on Earth forever. However, we can hit the brakes on the negative effects of the Great Acceleration and slow down the effects of terraforming. An example of change will be reducing the amount of methane in our atmosphere. Methane is a greenhouse gas that is 80 times more powerful than carbon dioxide, that began ticking up in the 1800s but skyrocketed in the 1900s, mirroring the global expansion of industry and agriculture. Between the 1950s and the 1970s, the acceleration of methane is 100 times what we saw in the previous 1,000 years. Currently, with human biomass already 100 times larger than any other large animal species that has ever walked the earth, and since methane is emitted by everything from oil wells to rice fields to belching cows, methane levels in our atmosphere has only continued to grow. However, unlike carbon dioxide, methane in the atmosphere dissipates after a decade, so if we start to make changes in land use and agriculture, there will be a drop-off in methane levels quickly. It is important to remember that we are all implicated from the consequences of terraforming, some more than others, but the tenacity and ingenuity that helped the Great Acceleration thrive can also help to pull these systems back to a safe place for all life on Earth. Recognizing and realizing these effects will be the dominant signal of the beginning to change. Thank you for tuning in. If you found this video informative, please leave a like and subscribe to the channel. See you in the next video.